Hello friends, welcome to the first video of communication. This is basically a subject for ECE students. Now let's start with this. In communication, we have two parts. One is analog and other one is digital. Okay, so in analog we have a continuous signal, continuous message signal which has to be transferred from one place to other, and in digital we have discrete time signal, discrete in time as well as discrete in amplitude. So what we basically do in communication, we have a message signal and we transfer it to some other place by using modulation. So what is modulation? The first thing this is actually a first session, so we will talk about basic things. In modulation, we try to translate the message signal to some higher frequency. Okay, translates to higher frequency. So the advantage of translating it to higher frequency are many. It reduces antenna size. Okay, it it is used for multiplexing. Multiplexing is actually combining two or more signals to transfer to some same channel, to transfer it through the same channel. Okay, and then third one is to reduce the effect of noise over the signal. Okay, so what are our message signal? Message signals are actually in the range of 300 hertz to 3.5 kilohertz. That is for voice signal. Okay, and 20 hertz to 20 kilohertz for audio signals. So voice signal and audio signals are the main message signals that we use to transfer. Okay, so this was regarding modulation and the message signal. Okay, and so basic thing before we start communication, we need to know something about Fourier transform. So Fourier transform is actually the message signal in time domain can be represented in frequency domain through the using Fourier transform. So basic formula we have to remember: g of f is integration g of t to the minus g. Now here g of t is our message signal in time domain, and we are converting it to frequency domain. This is message signal in frequency domain. So we have converted the message signal in time domain in frequency domain. Why we do this? Because in frequency domain we have many advantages, like convolution in time domain becomes multiplication in frequency domain. Okay, and it's better to use multiplication rather than convolution. Now inverse Fourier transform. So in inverse Fourier transform, we convert the frequency domain signal to time domain signal, which is given by g of t integration. So these are the basic formulas for Fourier transform. Okay, now some basic Fourier transform we have to remember, like Fourier transform of rectangular function. This is a basic rectangular function in time domain. The It varies from t by 2 to t by 2, minus t by 2 to plus t by 2, and the amplitude is a, which is constant over the time period. So if we find the Fourier transform of this by using this formula, we will get as at sinc of ft. Okay, now what is this sinc of ft? The sinc of ft is different from sine of ft, which is pi ft upon pi ft. Okay, so this is sinc of ft. The sinc function resembles like this. It has a main lobe over near the zero frequency, and it goes on decreasing after some, and this is 1 by t, minus 1 by t and 1 by t. Okay, now Fourier transform of delta of t is 1. This we can reduce from this rectangular function, like the width of this rectangular function is inversely proportional to width of this Fourier transform in frequency domain. So if we go on reducing the width of this rectangular function, we will get something like this, and this lobe will become large and large, so it will resemble like this. Okay, now one more property we have to remember is modulation property. This is very important because we will use this many times in our coming sessions. It states like g of t into cos of 2 pi fct. The Fourier transform of this function will be g of f minus fc plus g of f plus fc divided by 2, where g of f is actually the Fourier transform of g of t. If g of t is something like this and its Fourier transform g of f is suppose like this. Okay, so if g of t into cos 2 pi fct is used, and the Fourier transform will be f minus fc, this is 0, so f minus fc will be shifted to the positive half of the frequency cycle, and f plus fc will be this. This is fc, this is fc, this is minus fc actually. Okay, so this is actually called modulation property because we have translated the signal g of t, which was a baseband signal accumulated near zero frequency. We have translated it to plus fc and minus fc. So these were the basic things that were required to study further for analog communication. We'll see in the next session. Thanks.